Question 5. So the distance is the area under a velocity time graph. So the distance under this graph must equal 100. So we know the area of this triangle, this rectangle and this trapezium here all together add up to 100. So let's take each in turn. So the triangle, area of a triangle is half times base times height, so half times t times 15. The area of this rectangle, well, the base is 6 minus t times the height of 15. And remember, an area of a trapezium is the average of the parallel sides. Well, we know this height is 15, but to start with, we don't know that what this height here is. So let's just consider this journey while we decelerate from here to here. So using v equals u plus at, we've got an initial speed of 15, a final speed v which is unknown, a deceleration of 1.75, so in other words an acceleration of minus 1.75, and we know the time taken for this journey between 6 and 10 is 4 seconds. So substituting into v equals u plus at, we get v being 8. So back to working out the area of our trapezium, the average of the parallel sides, so a height of 15 and a height of 8, 15 plus 8 over 2 times the distance between, which is 4. So this allows us to multiplying out, so this middle term 15 times 6, 15 times minus t gives us this. So gathering up our t's, rearranging, we get t being 4.8 newtons. Now for part 2, show that the speed of the robot is this. Well, this is the displacement, this is the distance travelled. So if we differentiate this, we get the velocity of the robot. So differentiating this, so multiplying by the current power and reducing the power by 1, we get the velocity of the robot being 6t minus 0.6t squared. Substituting in t being 5, we get 15 as required. Now for part 3, find the value of t when the decelerations are equal. Well, acceleration, to get acceleration, we differentiate velocity. So we need to differentiate this, giving us 6 minus 1.2t. Now we need this deceleration of the robot to be the same as that of the athlete, which we were told was the deceleration was 1.75, so the acceleration is minus 1.75. So making this equal to minus 1.75, rearranging, we get t being 6.46 seconds. Now for part 4, verify that the athlete and the robot reach the finish line simultaneously. Well, we know the athlete took exactly 10 seconds to travel the 100 meters. So if we substitute this 10 seconds into the robot's distance formula, we need to check we also get 100. So the distance traveled by the robot is this. So substituting 10 into this, we do indeed get 100 meters, so it also takes 10 seconds to cover 100 meters, showing that they reach this finish line simultaneously.